100 Facts about C++. Language Origins and Evolution. 1. C++ was created by Bjarne Stroustrup at Bell Labs in the early 1980s. 2. It was initially called C with classes, to emphasize its evolution from the C programming language. 3. The name, C++, reflects the incremental improvements over C, symbolized by the ++ operator in C. 4. C++ is a general-purpose, object-oriented programming language. 5. It supports both procedural and object-oriented programming paradigms. 6. C++ is often referred to as a superset of C, meaning it includes all the features of C and adds new ones. Key features and concepts. 7. C++ is known for its performance, making it suitable for system programming, game development, and high-performance computing. 8. It offers low-level memory manipulation, providing fine-grained control over resource allocation and deallocation. 9. C++ supports object-oriented programming principles, including encapsulation, inheritance, polymorphism, and abstraction. 10. Encapsulation in C++ allows bundling data and functions together into classes. 11. Inheritance enables creating new classes based on existing ones, promoting code reuse. 12. Polymorphism allows objects of different classes to be treated as if they were of the same type. 13. Abstraction focuses on the essential features of an object while hiding unnecessary details. 14. C++ has a rich standard library, STL, that provides a wide range of data structures and algorithms. 15. The STL includes containers like vectors, lists, maps, and sets. 16. It also offers iterators for traversing containers and algorithms for sorting, searching, and more. 17. C++ supports templates for creating generic code that can work with different data types. 18. Templates are used to implement data structures like vectors, lists, and maps. 19. C++ has a strong type system, which helps prevent errors and improves code reliability. 20. C++ supports exception handling for managing runtime errors gracefully. Memory management and pointers. 21. C++ offers both automatic and manual memory management. 22. Automatic memory management is handled by the compiler, using the stack for local variables. 23. Manual memory management is done using pointers, which store the memory addresses of variables. 24. Pointers require careful handling to avoid memory leaks and segmentation faults. 25. C++ introduced smart pointers to simplify memory management and reduce the risk of errors. 26. Smart pointers automatically deallocate memory when they go out of scope. Standard Template Library, STL. 27. The STL is a powerful collection of template classes and functions. 28. It provides containers, iterators, algorithms, and function objects. 29. Containers are used to store and organize data, such as vectors, lists, maps, and sets. 30. Iterators are used to traverse elements within containers. 31. Algorithms perform operations on containers, like searching, sorting, and merging. 32. Function objects are objects that can be used as function arguments. C++ 1.1 and beyond. 33. C++ 1.1 introduced significant new features and improvements to the language. 34. Lambda expressions allow defining anonymous functions. 35. Range-based for loops simplify iteration over containers. 36. Nullpter is a distinct type for representing null pointers. 37. Move semantics improves performance by avoiding unnecessary copies. 38. Variadich templates enable functions and classes to accept a variable number of arguments. 39. Thread support is built into the language for multi-threaded programming. 40. Regular expressions are provided for pattern matching. 41. Type inference with auto makes code more concise. 42. Uniform initialization provides a consistent syntax for initializing variables. C++ 1.4, C++ 1.7, and C++ 2.0. 43. C++ 1.4 introduced additional features like generic lambdas and const.xpr functions. 44. C++ 1.7 added structured bindings for unpacking tuples and pairs. 45. It also included if-init statements and fold expressions. 46. C++ 2.0 brought concepts for more expressive templates and coroutines for asynchronous programming. C++ usage and applications. 47. C++ is widely used in system programming, such as operating systems and device drivers. 48. It is popular for game development due to its performance and control over hardware. 49. C++ is used in embedded systems for applications like IoT devices and industrial automation. 50. It is a common choice for high-performance computing and scientific simulations. 51. C++ is used in server-side development, including web applications and databases. 52. It is suitable for compiler development and 3D graphics. C++ community and standards. 53. C++ has a large and active developer community. 54. There are numerous online forums, mailing lists, and conferences dedicated to C++. 55. The C++ Standards Committee oversees the evolution of the language. 56. The committee is responsible for developing new language features and standards. 57. The latest C++ standard is C++ 2.0. Miscellaneous facts. 58. C++ is a strongly typed language, meaning that variables have specific data types. 59. C++ supports both pass-by-value and pass-by-reference for function arguments. 60. The main function is the entry point of a C++ program. 61. C++ has a rich set of operators, including arithmetic, comparison, logical, and bitwise operators. 62. C++ supports operator overloading, allowing operators to be redefined for custom data types. 63. C++ has multiple inheritance, where a class can inherit from more than one base class. 64. C++ offers virtual functions for dynamic polymorphism. 65. C++ has a preprocessor that allows for conditional compilation and macro definitions. 66. C++ supports namespaces to organize code and avoid naming conflicts. 67. C++ has exception specifications to declare the types of exceptions a function can throw. 68. C++ has explicit conversion operators to control type conversions. 69. C++ has const_expr functions for compile time computations. 70. C++ has dec type to infer the type of an expression. 71. C++ has template aliases for simplifying template declarations. 72. C++ has concepts for expressing constraints on template parameters. 73. C++ has coroutines for asynchronous programming. 74. C++ has modules for organizing code into separate compilation units. 75. C++ has ranges for expressing operations over sequences of elements. 76. C++ has views for transforming and filtering ranges. 77. C++ has synchronization primitives like mutexes and semaphores for multi-threaded programming. 78. C++ has atomic operations for thread-safe access to shared variables. 79. C++ has memory ordering guarantees for consistent memory accesses in multi-threaded programs. 80. C++ has exceptions for handling runtime errors. 81. C++ has RAII, resource acquisition is initialization, for automatic resource management. 82. C++ has placement new for allocating objects at specific memory locations. 83. C++ has type traits for querying information about types. 84. C++ has const_expr if for conditional compilation based on constant expressions. 85. C++ has template specialization for customizing template behavior for specific types. 86. C++ has variadage templates for creating templates that can accept a variable number of arguments. 87. C++ has fold expressions for applying operations to all elements of a pack. 88. C++ has structured bindings for unpacking tuples and pairs. 89. C++ has if-init statements for declaring and initializing variables within if conditions. 90. C++ has range-based for loops for iterating over containers. 91. C++ has lambda expressions for creating anonymous functions. 92. C++ has nullpter for representing null pointers. 93. C++ has move semantics for avoiding unnecessary copies. 94. C++ has thread support for multi-threaded programming. 95. C++ has regular expressions for pattern matching. 96. C++ has type inference with auto for simplifying variable declarations. 97. C++ has uniform initialization for consistent syntax for initializing variables. 98. C++ has const XPR functions for compile time computations. 99. C++ has dec type for inferring the type of an expression. 100. C++ has template aliases for simplifying template declarations.